Good day, this is IT 313 Systems Analysis and Design. Chapter 4, Managing Systems Projects. This chapter explains project management for IT projects. You will learn about project planning, scheduling, monitoring, reporting, and the use of project management software. You will learn how to create a work breakdown structure, identify task patterns, and calculate a critical path. You will also learn how to use Gantt charts and PERT CPM techniques to schedule and monitor projects. Finally, you will learn how to control and manage project changes as they occur. Building construction and systems development project both need careful management and monitoring. The only difference is the nature of the project. Project management for IT professionals includes first, planning, second, we have scheduling, monitoring and controlling, and reporting on information systems development. In developing a project, we must all consider the budget, time, and quality. We must be able to complete the project on time within the given budget by our client or the organization that we will be working on with, and deliver a quality product that satisfies users and meets their requirements. Project management techniques can be used throughout the system development life cycle, or what we call our SDLC. System developers can initiate a formal project as early as the preliminary investigation stage, or later on as analysis, design, and implementation activities occur. For a project to be successful, the factors budget, time, and quality must always be in balance. However, if one factor changes, adjustments must be made because the factors interact constantly. That is also the time a project manager must respond quickly. For example, if an extremely time-critical project starts to slip, the project manager might have to trim some features, seek approval for a budget increase, simplify the testing plan, or a combination of all three actions. In any kind of project, a good leader is important. Having a good leader contributes to the success of the project. In a systems project, the project manager or project leader usually is a senior systems analyst or an IT department manager if the project is large. An analyst or a programmer might manage smaller projects. In addition to the project manager, most large projects have a project coordinator who handles administrative responsibilities for the team and negotiates with users who might have conflicting requirements or want changes that would require additional time or expense, considering that the time, budget, and quality should always be balanced to have a successful project. The project managers typically perform 4 activities or functions. First, we have planning. Second, scheduling. Third is monitoring. And the fourth one is reporting. Project planning includes identifying all project tasks and estimating the completion time and cost of each, which means that in this activity, the project manager should identify clearly what has to be done, and as well as the project manager must be able to give the clients the estimated start date of the project and end date of that specific project. Next to it is the project scheduling, which involves the creation of a specific timetable, usually in the form of charts that show tasks, task dependencies, and critical tasks that might delay the project. Scheduling also involves selecting and staffing the project team and assigning specific tasks to team members. Project scheduling uses Gantt charts and PERT CPM charts, which are explained in the following sections. So this means that in this activity, the project manager will be able to give the specific time and also the tasks of the team members. What are the roles and responsibilities of each team member? Next, or the third activity of a project manager is project monitoring, which requires guiding, supervising, and coordinating the project team's workload. The project manager must monitor the progress, evaluate the results, and take corrective action when necessary to control the project and stay on target. One main goal or responsibility of a project manager is to check or to ensure that the given task to each team members are being done for the project to be successful, for the project to be released on time to their clients. And the fourth activity is project reporting, which includes regular progress reports to management, users, and the project team itself. Effective reporting requires strong communication skills and a sense of what others want and need to know about the project. In reporting, proper communication or effective communication with all the stakeholders involved in the project must be done by the project manager. For us to again ensure that we are on track or we are still on the target time, budget, and quality of the project that we want to achieve at the end. On any given day, a project manager might perform one or more of the activities. However, each activity is part of a larger framework which includes 3 key steps in project planning. First step is to create a work breakdown structure. Second is to identify the task patterns. And the last one is to calculate the critical path, as you can see from the matrix. The matrix is a typical sample of management activities performed while the project is being developed and when it is launched. Step 1 is to create a work breakdown structure or WBS, which involves breaking a project down into a series of smaller tasks. Before creating work breakdown structures, you should understand the 2 primary chart types, which are Gantt charts and PERT CPM charts. Gantt charts were developed almost 100 years ago by Henry L. Gantt, a mechanical engineer and a management consultant. His goal was to design a chart that could show planned and actual process on a project. A Gantt chart is a horizontal bar chart that represents a set of tasks. As you can see in the figure below, it displays 5 tasks in a vertical array with time shown on a horizontal axis. The position of the bar shows the planned starting and ending time of each task, and the length of the bar indicates its duration. On the horizontal axis, time can be shown as elapsed time from a fixed starting point or as actual dates. A Gantt chart also can simplify a complex project by combining several activities into a task group. A Gantt chart can show task status by adding a contrasting color to the horizontal bars. For example, a vertical arrow marks the current date as shown in the figure. With a fixed reference point, it is easy to see that Task 1 is way behind schedule. Task 2 is only about 80% done and is running behind schedule. Task 3 should have started, but no work has been done. Task 4 actually is running ahead of schedule, and Task 5 will begin in several weeks. Gantt charts can present an overview of the project status, but they do not provide enough detailed information which is necessary when managing a complex project. Most project managers find that PERT CPM charts, which are discussed in the following section, are better tools for managing large projects. The Program Evaluation Review Technique, or PERT, was developed by the U.S. Navy to manage very complex projects, such as the construction of nuclear submarines. At approximately the same time, the Critical Path Method, or CPM, was developed by private industry to meet similar project management needs. The distinction between the two methods has disappeared over time, and today the technique is called either PERT CPM or PERT CPM. PERT is a bottom-up technique because it analyzes a large complex project as a series of individual tasks. To create a PERT chart, first, you must identify all the project tasks and estimate how much time each task will take to perform. Next, you must determine the logical order in which the task must be performed. For example, some tasks cannot start until other tasks have been completed. In other situations, several tasks can be performed at the same time. In other words, some tasks are dependent upon the completion of the other tasks. On the other hand, some tasks can be done or can be completed simultaneously with the other tasks. Once you know the tasks, their durations, and the order in which they must be performed, you can calculate the time that it will take to complete the project. You also can identify the specific tasks that will be critical to the project's on-time completion. Although a Gantt chart offers a valuable snapshot view of the project, PERT charts are more useful for scheduling, monitoring, and controlling the actual work. With a PERT chart, a project manager can convert task start and finish times to actual dates by laying out the entire project on a calendar. Then, on any given day, the manager can compare what should be happening with what is taking place and react accordingly. Also, a PERT chart displays complex task patterns and relationships. This information is valuable to a manager who is trying to address high-priority issues. PERT and Gantt charts are not mutually exclusive techniques, and project managers often use both methods. Identifying tasks in a work breakdown structure, or WBS. A work breakdown structure must clearly identify each task and include an estimated duration. A task or activity is any work that has a beginning and an end and requires the use of company resources such as people, time, or money. Examples of tasks include conducting interviews, designing a report, selecting software, waiting for the delivery of equipment, or training users. Tasks are basic units of work that the project manager plans, schedules, and monitors. So they should be relatively small and manageable. In addition to tasks, every project has events or milestone. An event or milestone is a recognizable reference point that you can use to monitor progress. For example, an event might be the start of user training, the conversion of system data, or completion of interviews. A milestone such as complete 50% of program testing would not be useful information unless you could determine exactly when that event will occur. Listing the tasks. While this step sounds simple, it can be challenging because the tasks might be embedded in a document. For example, the tasks or the listed tasks are: first, reserve the meeting room. Then, order the marketing materials and brief the managers. After the briefings, send out customer emails and burn sample DVDs. When the emails are sent and the DVDs are ready, load the new software. When the marketing materials have arrived and the software is ready, do a dress rehearsal. One trick that you can do is to highlight the individual tasks. You can also add bullets that will make the task stand out more clearly. The next step is to number the tasks and create a table, similar as you can see on the figure, with columns for task number, description, duration, and predecessor tasks. In this example, we have task number 1, reserve the meeting. Number 2, order the marketing materials. 3, brief the managers. 4, send out customer emails. 5, burn sample DVDs. 6, load the new software. And 7, do a dress rehearsal. Estimating task duration. Task duration can be hours, days, or weeks, depending on the project. Because the following example uses days, the units of measurement are called person days. A person day represents the work that one person can complete in one day, meaning we will be using the ratio work of one person is to 1 day. This approach, however, can present some problems. For example, if it will take one person 20 days to perform a particular task, it might not be true that 2 people could complete the task in 10 days or that 10 people could perform the task in 2 days. Some tasks can be divided evenly, so it is possible to use different combinations of time and people, up to a point. For instance, if it takes 2-person day to install the cables for a new local area network, 1 person might do the task in 2 days, 2 people in 1 day, or 4 people in half a day. In most system analysis tasks, however, time and people are not interchangeable. If one analyst needs 2 hours to interview a user, 2 analysts also will need 2 hours to do the same interview. Project managers often use a weighted formula for estimating the duration of each task. The project manager first makes 3 time estimates of each task. First one is the optimistic or best case estimate, which we refer as B. Second is a probable case estimate, which we refer as P. And a pessimistic or worst case estimate, which we refer as W. The manager then assigns a weight, which is an importance value, to each estimate. The weight can vary, but a common approach is to use a ratio of B is equal to 1, P is equal to 4, and W is equal to 1. The expected task duration is calculated with the given formula B plus 4P plus W over 6. For example, a project manager might estimate that the file conversion task could be completed in as few as 20 days or could take as many as 34 days, but most likely will require 24 days. Using the formula, the expected task duration is 25 days. Calculated using the given formula B plus 4P plus W over 6, we can substitute the values, wherein B is equivalent to 20, P is equivalent to 24, and W is equivalent to 34. Then, from that, we could have the expected task duration, which is 25 days. When developing duration estimates, project managers consider 4 factors. We have our project size and scope, human resources, experience with similar projects, and constraints. Step 2 is to identify task patterns. Tasks in a work breakdown structure must be arranged in a logical sequence called a task pattern. In any project, large or small, tasks depend on each other and must be performed in a sequence, not unlike the commands in a software program. Task patterns can involve dependent tasks, multiple successor tasks, and multiple predecessor tasks. In larger projects, these patterns can be very complex, and an analyst must study the logical flow carefully. In a PERT CPM chart, project tasks are shown as rectangular boxes arranged in the sequence in which they must be performed. Each rectangular box, called a task box, has 5 sections. First, we have our task name, task ID, task duration, start day or date, and finish day and date. We have here our task box format, including the important information. Let's start with task name. The task name should be brief and descriptive, but it does not have to be unique in the project. For example, a task name conduct interviews might occur in several phases of the project. Next one is the task ID. It can be a number or code that provides unique identification. When we say unique identification, it should not be repeated within the project. Task duration. The task duration is the amount of time it will take to complete a task. All tasks use the same time units, which can be hours, days, weeks, or months. Again, it will depend on the project. An actual project starts on a specific date, but can also be measured from a point in time such as day 1. Again, you can use a specific day or day depending on the need on the project. Start day or date is the time that a task is scheduled to begin. For example, suppose that a simple project has 2 tasks, task 1 and task 2. Also suppose task 2 cannot begin until task 1 is finished. An analogy might be that you cannot run a program until you turn on your computer. If task 1 begins on day 1 and has a duration of 3 days, it will finish on day 3. Because task 2 cannot begin until task 1 is completed, the start time for task 2 is day 4, which is the day after task 1 is finished. Then, the finished day or date is the time that a task is scheduled to be completed. To calculate the finished day or date, you add the duration to the start day or date. When you do this, you must be very careful not to add too many days. For example, task starts on day 10 and has a duration of 5 days, then the finish will be on day 14 and not on day 15. A project is based on a pattern of tasks. In a large project, the overall pattern would be quite complex, but it can be broken down into 3 basic patterns. First is the dependent tasks, second, multiple successor tasks, and third, multiple predecessor tasks. Dependent task is when tasks must be completed one after another, just like a relay race. You need to wait for your team member to finish before you can start. Multiple successor tasks is when several tasks can start at the same time, or can be called as concurrent tasks. Often, 2 or more concurrent tasks depend on a single prior task, which is called a predecessor task. In this situation, each concurrent task is called successor task. Multiple predecessor tasks is when it requires 2 or more prior tasks to be completed before it can start. You can identify task patterns by looking carefully at the wording of the task statement. Words like then, when, or end are action words that signal a sequence of events. For example, do task 1, then do task 2 describes dependent tasks that must be completed one after the other. Another example is when task 2 is finished, start 2 tasks, task 3 and task 4. This describes multiple successor tasks that can both start as soon as task 2 is finished. Another example is when tasks 5 and 6 are done, start task 7. Indicates that task 7 is a multiple predecessor task because it cannot start until 2 or more previous tasks all are completed. When several task patterns combine, you must study the facts very carefully to understand the logic and sequence. A project schedule will not be accurate if the underlying task pattern is incorrect. Consider the following 3 fact statements and the task patterns they represent. First one is the dependent task. So the diagram shows that we have to perform task 1. When task 1 is complete, perform task 2. The next one is dependent task and the multiple successor tasks. So the diagram shows that we have to perform task 1. When task 1 is complete, perform task 2. When task 2 is finished, start 2 tasks, task 3 and task 4. When task 3 is complete, start 2 more tasks, task 5 and task 6. Then last one is dependent tasks, multiple successor tasks, and multiple predecessor tasks. The diagram shows that we have to perform task 1. When task 1 is complete, perform task 2. When task 2 is finished, start 2 tasks, task 3 and task 4. When task 3 is complete, start 2 more tasks, task 5 and task 6. When tasks 5 and 6 are done, start with task 7. Then, when tasks 4 and 7 are finished, perform task 8. We are now on our step 3, which is to calculate the critical path. The task patterns determine the order in which the tasks are performed. Once the task sequence has been defined, the project manager can schedule the tasks and calculate the critical path. A critical path is a series of tasks which, if delayed, would affect the completion date of the overall project. If any task on the critical path falls behind schedule, the entire project will be delayed. For example, suppose that you invite Joanne and Jim to your home for dinner. Joanne arrives on time, but Jim arrives 30 minutes late. Jim's arrival is part of the critical path because you do not want to start without him. So the meal will be served 30 minutes later than originally planned. The figure shows a training project with 5 tasks. Notice that the analyst has arranged the tasks and entered the important information such as task name, IDs, and durations. First, you should review the task pattern. So the task pattern in this example is that task 1 is followed by task 2, which is dependent task. Task 2 has 2 successor tasks, which is task 3 and task 4. Task 3 and 4 are predecessor tasks for task 5. Task 1 starts on day 1 and has a duration of 10 days. So the finish date is day 10. Task 2, which is dependent on task 1, can start on day 11, the day after task 1 ends. With a duration of 30 days, task 2 will end on day 40. Task 3 and 4 are multiple successor tasks that can start after task 2 is done. Task 2 ends on day 40, so task 3 and 4 both can start on day 41 or the day after task 2 has been completed. Task 3 has a duration of 5 days and will end on day 45. Task 4 has a duration of 25 days and will not end until day 65. Task 5 depends on task 3 and 4, which are multiple predecessor, Because task 5 depends on both tasks, it cannot start until the later of the two tasks is complete. In this example, task 3 ends earlier, but task 4 will not be completed until day 65. So, task 5 cannot start until day 66. Recall that a critical path is a series of tasks which, if delayed, would affect the final completion date of the overall project. In this example, tasks 1 and 2 are the first tasks on the critical path. Now look at task 5, which cannot start until both tasks 3 and 4 are done. In this case, task 4 is the controlling factor because task 4 finishes on day 65, which is 20 days later than task 3, which is completed on day 45. Therefore, the start date for task 5 is determined by the finish date for task 4. In contrast, task 3 has slack time and could be delayed up to 20 days without affecting task 5. Slack time, as we define, is the amount of time that the task could be late without pushing back the completion date of the entire project, or it will not affect the completion date of the project. Tasks 1, 2, 4, 5 represent the critical path, which is highlighted with red arrows. Regardless of whether the project was planned and scheduled with project management software or in some other manner, the project manager must keep track of the tasks and progress of team members, compare actual progress with the project plan, verify the completion of project milestone, and set standards and ensure that they are followed. To help ensure that quality standards are met, many project managers institute structured walkthroughs. A structured walkthrough is a review of a project team member's work by other members of the team. Generally, systems analysts review the work of other systems analysts, and programmers review the work of other programmers as a form of peer review. Structured walkthroughs take place throughout the system's development life cycle and are called design reviews, code reviews, or testing reviews depending on the phase in which they occur. Maintaining a project schedule can be challenging, and most projects run into at least some problems or delays. By monitoring and controlling the work, the project manager tries to anticipate problems, avoid them or minimize their impact, identify potential solutions, and select the best way to solve the problem. The better the original plan, the easier it will be to control the project. If clear, verifiable milestone exists, it will be simple to determine if and when those targets are achieved. If enough milestones and frequent checkpoints exist, problems will be detected rapidly. A project that is planned and scheduled with PERT CPM can be tracked and controlled using these same techniques. As work continues, the project manager revises the plan to record actual times for completed tasks and revises times for tasks that are not yet finished. Project managers spend most of their time tracking the tasks along the critical path because delays in those tasks have the greatest potential to delay or jeopardize the project. Other tasks cannot be ignored. However, for example, suppose that a task not on the critical path takes too long and depletes the allotted time. At that point, the task actually becomes part of the critical path, and any further delay will push back the overall project. Members of the project team regularly report their progress to the project manager, who in turn reports to management and users. The project manager collects, verifies, organizes, and evaluates the information he or she receives from the team. Then the manager decides which information needs to be passed along, prepares a summary that can be understood easily, adds comments and explanations if needed, and submits it to management and users. Project managers schedule regular meetings to update the team and discuss project status, issues, problems, and opportunities. Although meetings can be time-consuming, most project managers believe they are worth the effort. The sessions give team members an opportunity to share information, discuss common problems, and explain new techniques. The meetings also give the project manager an opportunity to seek input and conduct brainstorming sessions. A project is in trouble, but the project manager is reluctant to report the problems. The case highlights important ethical issues that often arise in this situation. A project manager must report regularly to his or her immediate supervisor, upper management, and users. Although a progress report might be given verbally to an immediate supervisor, reports to management and users usually are written. Gantt charts often are included in progress reports to show project status graphically. Deciding how to handle potential problems can be difficult. At what point should you inform management about the possibility of cost overruns, schedule delays, or technical problems? At one extreme is the overly cautious project manager who alerts management to every potential snag and slight delay. The danger here is that the manager loses credibility over a period of time, and management might ignore potential serious situations. At the other extreme is the project manager who tries to handle all situations single-handedly and does not alert management until a problem is serious. By the time management learns of the problem, little time might remain in which to react or devise a solution. So the lesson there is that you'll always have to inform the management if there are existing problems. You can also inform or update your team regarding the specified problems. A project manager's best course of action lies somewhere between two extremes, but is probably closer to the first. If you are unsure of the consequences, you should be cautious and warn management about the possibility of a problem. When you report the situation, you also should explain what you are doing to handle and monitor the problem. If you believe the situation is beyond your control, you might want to suggest possible actions that management can take to resolve the situation. Most managers recognize that problems do occur in most projects. It is better to alert management sooner rather than later. In other words, it is the project manager's responsibility to inform whatever is happening with regards with the development of the project. Project managers use powerful software to help plan, schedule, monitor, and report on a project. Most project management programs offer features such as PERT CPM, Gantt charts, resource scheduling, project calendar, and cost tracking. Microsoft Project is a full-featured project management program that holds the dominant share of the market. On the web, Microsoft offers demo versions, trainings, and tips. Although Microsoft is the industry leader, many other vendors offer project management software, and you can explore these options by searching on the web. One product is the Open Workbench, which is available as free software, complete with manuals and sample projects. You can download the latest version from the Open Workbench site. We have already discussed how to create a work breakdown structure. If you are using Microsoft Project or Open Workbench, the process is exactly the same. You must identify the tasks, durations, and task patterns. You might have to develop this information on your own, or you might work with a task summary. Your manager would like you to create a Gantt chart and a PERT chart that show all tasks, dependencies, dates, and total project duration. Your first step is to create a Gantt chart showing the necessary information. You decide to use Microsoft Project to construct the chart. As you enter each task, you also enter the duration and the predecessor task, if any. As you enter the task, duration, and predecessor task, the program automatically performs the calculations, detects the task patterns, and creates a Gantt chart similar to the one that is shown on the figure. The chart consists of 12 horizontal bars connected with arrows that indicate the task dependencies. Notice that Saturdays and Sundays are shown as shaded columns because no work will be performed on those days. The program makes these adjustments automatically. For example, Task 2, which has a duration of 3 days, starts on Thursday and ends on Monday. After you complete the Gantt chart, you decide to view the data in the form of a Microsoft Project Network diagram, which is similar to a PERT chart. When you select the Network Diagram option on the View menu, you can see the project tasks and dependencies. You study the diagram and see that the program has calculated a start and finish date for each task. Notice that the diagram displays the same information as the Gantt chart, including task dependencies, and also includes a red line that indicates the project's critical path. According to the diagram, project remains on schedule. The last task will be completed on Friday, October 14, 2011. Notice that the task boxes in the Microsoft Project are similar to PERT CPM task boxes. Using Microsoft Project, you can assign each task to one or more people, assign budget targets, produce progress reports, and readjust schedules and deadlines as necessary. Every IT project involves risks that systems analysts and project managers must address. A risk is an event that could affect the project negatively. Risk management is the process of identifying, analyzing, anticipating, and monitoring risks to minimize their impact on the project. The first step in risk management is to develop a specific plan. Although project management experts differ with regard to the number of steps or phases, a basic list would include the following tasks. First is to develop the said risk management plan, which includes a review of the project scope, stakeholders, budget, schedule, and any other internal or external factors that might affect the project. The plan should define project roles and responsibilities, risk management methods and procedures, categories of risk, and contingency plans. Next is to identify the risk or risk identification. It lists out each risk and assesses the likelihood that it could affect the project. The details would depend on the specific project, but most lists would include a means of identification and a brief description of the risk, what might cause it to occur, who would be responsible for responding, and the potential impact of the risk. Next one is to analyze the risk. This typically is a two-step process, which includes qualitative risk analysis and quantitative risk analysis. Qualitative risk analysis evaluates each risk by estimating the probability that it will occur and the degree of impact. Project managers can use a formula to weigh risks and impact values, or they can display the results in a two-axis grid. So for example, we have in our Microsoft Excel, the X and Y chart. So it can be used to display the matrix as shown in the figure. In the chart, notice the various combinations of risk and impact ratings for the 5 sample values. This tool can help a project manager focus on the most critical areas where risk, probability, and potential impact are high. The purpose of a quantitative risk analysis is to understand the actual impact in terms of dollars, time, project scope, or quality. Quantitative risk analysis can involve a modeling process called what-if analysis, which allows a project manager to vary one or more elements in a model to measure the effect on other elements. Next is to create a risk response plan, which is a proactive effort to anticipate a risk and describe an action plan to deal with it. An effective risk response plan can reduce the overall impact by triggering timely and appropriate action. Then last one is to monitor the risk. This activity is ongoing throughout the risk management process. It is important to conduct a continuous tracking process that can identify new risks, notice changes in existing risks, and update any other areas of the risk management plan. Most project management software includes powerful features that allow a project manager to assign specific dates as constraints, align task dependencies, note external factors that might affect a task, track progress, and display tasks that are behind schedule. In addition, some vendors offer risk management add-ons. The Enterprise Edition of Microsoft Project or the Microsoft Project Server 2010 has a built-in risk management capability that can be used for large corporate-wide projects. Microsoft claims that the software can link risks with specific tasks and projects, specify probability and impact, and assign ownership and track progress to manage projects more efficiently. Microsoft's risk management model includes the following factors. First is the probability, which represents the likelihood that a risk will happen expressed as percentage. The impact, which indicates the degree of adverse effect should the risk occur on a scale of 1 to 10. Cost, which indicates the potential financial impact of the risk. Category, which specifies the risk type. The description, which specifies the nature of the risk. The mitigation plan, which identifies plans to control or limit the risk. The contingency plan, which specify actions to be taken if the risk occurs. And trigger, which identifies a condition that would initiate the contingency plan. Armed with this information, the IT team can make a recommendation regarding the risks associated with the project. Depending on the nature and magnitude of the risk, the final decision might be made by management. To be successful, an information system must satisfy business requirements, stay within budget, be completed on time, and most important of all, be managed effectively. When a project develops problems, the reasons typically involve business, budget, or schedule issues. In addition to planning and managing the project, a project manager must be able to recognize problems and deal with them effectively. The major objective of every system is to provide a solution to a business problem or opportunity. If the system does not do this, then it is a failure. Regardless of positive reaction from users, acceptable budget performance, or timely delivery, when the information system does not meet business requirements, causes might include unidentified or unclear requirements, inadequately defined scope, imprecise targets, shortcuts or sloppy work during systems analysis, poor design choices, insufficient testing or inadequate testing procedures, and lack of change control procedures. Systems also fail because of changes in the organization's culture, funding, or objectives. A system that falls short of business needs also produces problems for users and reduces employee morale and productivity. Projects without clear scope definitions are risky because they tend to expand gradually without specific authorization in a process called project creep. However, even when a project is clearly described, it must be managed constantly. Budget issues. Cost overruns typically result from one or more of the following: unrealistic estimates that are too optimistic or based on incomplete information, failure to develop an accurate forecast that considers all costs over the life of the project, poor monitoring of progress and slow response to early warning signs of problems, schedule delays due to factors that were not foreseen, human resource issues including turnover, inadequate training, and motivation. Problems with timetables and project milestone can indicate a failure to recognize task dependencies, confusion between effort and progress, poor monitoring and control methods, personality conflicts among team members, or turnover of project personnel. The failure of an IT project can also be caused by poor project management techniques. If the project manager fails to plan, staff, organize, supervise, communicate, motivate, evaluate, direct, and control properly, then the project is certain to fail. Even when factors outside his or her control contribute to the failure, the project manager is responsible for recognizing the early warning signs and handling them effectively. Project management is a challenging task. Project managers must be alert, technically competent, and highly resourceful. They also must be good communicators with strong human resource skills. A project manager can be proud when he or she handles a successful project that helps the company achieve its business objectives. Unfortunately, projects can and do get derailed for a wide variety of reasons. When problems occur, the project manager's ability to handle the situation becomes the critical factor. When a project manager first recognizes that a project is in trouble, what options are available? Alternatives can include trimming the project requirements, adding to the project resources, delaying the project deadline, and improving management controls and procedures. Sometimes, when a project experiences delays or cost overruns, the system still can be delivered on time and within budget. If several less critical requirements are trimmed, the system can be delivered to satisfy the most necessary requirements, and additional features can be added later as a part of a maintenance or enhancement project. If a project is in trouble because of a lack of resources or organizational support, management might be willing to give the project more commitment and higher priority. For example, management might agree to add more people to a project that is behind schedule. Adding staff, however, will reduce the project's completion time only if the additional people can be integrated effectively into the development team. Adding staff can mean training and orienting the new people. In some situations, adding more people to a project actually might increase the time necessary to complete the project because of a principle called Brooks' Law. This interesting concept was stated by Frederick Brooks, Jr., an IBM engineer, who observed that adding manpower to its software project only makes it later. Brooks reached this conclusion when he saw that new workers on a project first had to be educated and instructed by existing employees whose own productivity was reduced accordingly. This is an additional discussion regarding on how you can calculate the expected time or estimated task duration. Given are the activities A, B, C, D, E, F, G, and H, with the predecessors as given on the table. We use the variable O for optimistic or the best case estimate, R variable for our probable case estimate, and P for our pessimistic or worst case estimate. And then we adopted the formula in computing the expected task duration or expected time. To get the expected time for activity A, we'll be adopting the formula. So we'll have to replace or substitute the variable O with 1, R with 5, and P with 9. And then, following the MDAS rule, So we'll have to conduct first the multiplication. So that would be 4 times 5. And then proceed with the addition. That would be 1 plus 20 plus 9. We'll have a sum of 30. Divide by 6. So that's why we have our expected time as 5. The same procedure, the same formula will be used for activities B to H. For those who have listened to this discussion, I will be expecting your answers or your solutions for activity B to H up until Friday. Please submit it to me to my GSUT account with the subject Project Management Activities Solution. What we have here is a simple network diagram for our example. To calculate the project duration, we'll just have to add the duration of all the activities. In this example, that would be 5 plus 6 plus 6 plus 2 plus 5.5 plus 5 plus 3 plus 1, which gives us our duration of 33.5 days. Based from our diagram, we could be able to identify the possible path. We have 3 paths. First is A, B, D, G, H. The second path is A, C, E, G, H. And the last path is A, C, F, G, H. To identify our critical path, we'll just have to add the duration for each activity in each path. For example, our first path, which includes A, B, D, G, H, with its corresponding duration as 5, 6, 2, 3, and 1, which gives us a sum of 17 days. Our second path with 20.5 days, and our third path which gives us 20 days. The boxes above each activity indicates the early start time and the early finish time of each activity. To calculate for our early start time, we can start by identifying on what day it started or on what day the predecessor activity ended. For example, for our activity A, so it started with day 0, and then we'll be adding the duration to the early start day to identify our early finish time. So that means that would be 0 plus 5, which gives us 5 as our early finish time. So that applies to all activities. For those who have watched this presentation, kindly send me your solution to my GSUT account. The boxes below our activity name is our late start time and our late finish time. To identify its value, we'll be using the backward pass. So that means we'll be starting with activity H. That means that we will be subtracting the duration from the late finish time. So starting with 20.5, we'll be subtracting 1 because 1 is the duration of our activity H. So that yields to 19.5. Same thing goes with activity G. So the late finish time of activity G is 19.5 minus its duration. Duration is 3 days, so that would give us 16 points. You must do the succeeding calculation for the next activities. Please send your solution again to my G Suite account. After identifying the early start time and the early finish time, as well as with the late start time and late finish time, we can now identify our slack time. To do that, we can use two formulas. First one, we can subtract the early start time from our late start time, or we can subtract our early finish time to our late finish time. For example, for our activity A, our late start time is 5 and our early start time is 5. 5 minus 5, that gives us 0. For our late finish time, we have 0 and our early finish time is 0. 0 minus 0, that gives us 0 as our slack time. Try to do the calculation of the slack time for the remaining activities and send your solutions to my G Suite account. Thank you for listening. God bless.